Welcome to this module of the Spirent Test Center course on Routing and MPLS Overview. This module, Routing and MPLS Overview, is covered in the presentation in the following slides. There's a separate presentation that everybody should view, whether you're doing routing and or MPLS. Of course, if you're doing MPLS, that generally includes some form of routing. So everybody should view the Routing Overview presentation too. There are separate presentations for each of the individual routing protocols as well as MPLS protocols. So the routing and MPLS topic overview, each one of these bullets will be covered on a separate slide in this presentation, so I'm not going to describe each one of them in sequence here. So routing and MPLS emulation with Spirent Test Center allows you to emulate various points of the network and various layer 2 and 3 protocols. So from the edge or the access layer of the network to the carrier Ethernet, maybe emulating protocols such as EAOM, as well as MPLS OAM protocols at the IP MPLS edge, emulating LSRs, LDP, RSVPTE, as well as various unicast routing protocols in the core of a network, even multiple protocol emulation for complex MPLS VPNs, and even data center emulation protocols. Spirent Test Center supports topology emulation to provide a very realistic emulation of all these different layers. Routing and MPLS emulation integrates with PGA, which was covered as a separate module. Packet Generator Analyzer refers to sending and receiving traffic across these network topologies. So there's quick and easy to use wizards for setting that up as well. Various features of Spirent Test Center's routing and MPLS emulation: the ability to emulate thousands of routers, millions of routes, over hundreds of ports per test. So very large scale tests and testing very large scale devices and networks can be accomplished running all common unicast, multicast, MPLS protocols and associated features of those. Spirent Test Center supports routing and MPLS emulation across a variety of different types of interfaces: Ethernet from 10 meg up to 10 gig, ATM interfaces, as well as packet over SONET test modules. There's complete IP version 6 support for all protocols where applicable. As discussed on a previous slide, you can emulate from the in to the access to the core to the access and back to the in testing, or any combination in between, using topology emulation as well. Spirent Test Center supports routing and MPLS emulation for performance, conformance, and functional, often referred to as negative testing as well. Graceful restart is supported for most protocols, as well as bidirectional forwarding detection. It also supports authentication modes with most protocols, and also routing and MPLS and traffic over GRI tunnel supports for control and data plane testing. This slide depicts, using the technology selector, the various routing and MPLS protocols emulated by Spirent Test Center. Essentially, Spirent Test Center emulates all the standard routing protocols for both unicast, multicast, and MPLS emulation, as well as complex scenarios of multiprotocol emulation for MPLS virtual private networks, both layer 2 and layer 3, and as I mentioned before, IPv6 simulation for various protocols as well. Just a quick note on routing and MPLS scalability with Spirent Test Center. As this note on the bottom says, this is an example only, but just to give you an idea that Spirent Test Center ports can emulate hundreds, even thousands of things from a single port, which is quite different than you might imagine. So a single Spirent Test Center port can emulate a whole network of devices and an entire core network topology. Routing emulation with Spirent Test Center is very similar as it is with setting up a real router. So you define a router interface and then enable and configure multiple protocols on it. That enables you to do multiple protocol emulation, but one difference is a single Spirent Test Center port can emulate hundreds or thousands of routers, and also there's a difference between Spirent Test Center emulated routers, which are real, and Spirent Test Center simulated routers, which actually don't exist, but we make it look like that to the device or network under tests. So a simple routing topology example showing the difference between emulated and simulated routers. In the graphic below you see the DUT, the device under test, in the middle, and directly connected to it are two separate emulated routers. Consider those on two separate Spirent Test Center ports, although a single Spirent Test Center port can emulate thousands of routers as well. So the emulated router is real. So for instance, if you're running BGP, it will actually form a BGP session with the DUT. If you're running OSPF, it will form an OSPF adjacency with the DUT. The simulated routers aren't real though, but we make it look like they do via our emulated routers. So for example, with BGP, we can send a BGP update with routes that are actually multiple ASs away. That makes it look like the simulated routers actually exist as separate autonomous systems, as though we learned the routes through them and we're re-advertising them with our emulated router. For OSPF, for example, our emulated router would forward the simulated router's LSA as if it received them in a real network via the OSPF flooding algorithm. To the device under test, it doesn't know that the simulated router's LSAs were actually originated by the emulated router. It just thinks it's forwarding them on. We're going to walk through various configuration features for setting up your tests with Spirent Test Center. So there's a separate slide or multiple slides for each one of these main bullets, whether it's device wizard integration for creating your devices, test wizard integration for creating large-scale topologies, even MPLS VPN topologies, or even sending large number of routes from individual protocols. There's various protocol configuration grids, or what we call spreadsheets. So I mentioned you might have hundreds of routers on a port and you want to change the autonomous systems for them all with just a copy down or fill increment type of function. For data plane testing, there's also the traffic wizard integration, where you can set up a device to advertise thousands of routes, and it's real easy to set up through the wizard the traffic to send to and from those routes. There's also support for creating individual frames that look like protocol frames. We talked about stream blocks in the PGA presentations. Stream block can be a raw stream block where you can just, via a frame editor, set up what looks like an OSPF update frame or an MPLS labeled frame, and then you can go in and manipulate the various parameters of that, maybe for negative testing as well. Via the GUI, there's also various summaries, especially for large-scale testing, to see how many routers I have overall in my tests on a port. For a router, how many protocols and or routes are enabled for it as well. And you can set up the entire test in a graphical interface and then export it to a script, and then manipulate and run the test outside of the GUI environment. So device wizard integration. You can create emulated routers via the device wizard, and you can create hundreds across multiple ports, all within one wizard session, even enabling dual stack support at the time for the protocols that support it. Via the device wizard, you can configure the layer 2 protocols depending on the port type. You can add VLAN IDs and so on. You could also enable one or more layer 3 protocols at once. So for multi-protocol emulation, through the device wizard, you can create a device that's simulating its IGP, its BGP, as well as its MPLS protocols, all through a single wizard session. And then depending on which protocols you have enabled, each protocol has a separate configuration screen in the wizard. So while in the wizard, even if you're creating hundreds of routers at one time, you can set up the parameters, set up the steps, so you can say how the AS number, for instance, will be applied across multiple routers on the same port or across multiple routers across different ports, and then various parameters for each protocol can be set up through the wizard as well. In addition, there's various test wizards. So test wizards configure everything end to end. So as you notice here, there's various MPLS test wizards. So you can create your IP, layer 3 IP VPNs and create all your emulated and simulated customer edge CE, provider P or provider edge routers, all within a single wizard session, creating hundreds of emulated entities. So these test wizards give you, in a graphical environment, a way to set up and visualize the topologies that you're creating. You can create very large-scale, complex tests with hundreds, even thousands of routers advertising millions of routes all through a single wizard session. You have access to many of the parameters of each protocol that you can set up through the wizard, such as setting the ASNs, bidirectional forwarding detection, or graceful restart, for example. There's wizards for setting up your MPLS, for RSVP TE, for configuring your traffic engineering and all the associated LSPs. There's multicast routing wizards for setting up either PIM for multicast routing emulation or just your multicast traffic and hosts. And from a VPN perspective, we support wizards for layer 2 VPNs, BGP, LDP, emulated pseudo wires, and even IP VPNs as well. I mentioned topology emulation a few slides ago as a way that Spirent Test Center supports more realism in the testing. So Spirent Test Center supports an object-oriented topology. You create devices which can run as routers, and those devices can be assigned various roles such as a customer edge router or a P router or a PE router. Now before we talked about emulated routers being directly connected and forming sessions, for example, with the DUT. Well, what if you have PE routers behind P routers? In this case, both of those are emulated. So the emulated PE router all the way on the right is actually behind another emulated P router on the same Spirent Test Center port, which may be running, let's say, MPLS. So all the attributes of that emulated PE router will be picked up by the traffic originating from the emulated PE router before it reaches the DUT. And that applies to both routing emulation as well as the traffic that we're sending to and from the routes over the LSPs as well. So these emulated routers behind emulated routers, sometimes we refer to them as device behind device. Whenever you have that situation, we refer to the connections between them as links. And links can be created as layer 2 links, where all the traffic and emulation picks up even the layer 2 attributes, such as VLAN IDs and stuff, or layer 3 links, where it picks up the emulated layer 3 emulation. In this example, the emulated CE router exchanges routing information with the DUT, and the emulated PE router exchanges routing and label signaling with the DUT, building an emulated MPLS topology. The emulated BGP routers are connected to the CE and PE routers using links. The links associate the connection between the devices and provide a mechanism to encapsulate the control plane traffic between them for transport. The control plane binding is dynamic. All you need to do is define them and associate them, and Spirent Test Center does the rest. So for instance, when we're sending traffic across these emulated links and the traffic flows through an emulated router and it's running MPLS, whatever MPLS label that was assigned can be picked up by the traffic automatically, even if it changes during the test. This gives you an example of an MPLS IP VPN topology. So in this case, the DUT is a PE router connected to, on the left, a Spirent Test Center port that is running multiple emulated CE routers, possibly over VLAN IDs. On the right, Spirent Test Center is actually emulating the core, the P and the PE routers, as well as the simulated CE routers on the edge. And so all the IGP and BGP and MPLS emulation that's required to emulate this topology will be performed by Spirent Test Center. Spirent Test Center also supports generic routing encapsulation for both the emulation protocols as well as sending traffic across the GRI tunnels. As you can see here, you have access to the various parameters to define the tunnel endpoints. I mentioned earlier, from a data plane perspective, there's also integration with the traffic. So for instance, you have an emulated BGP router that's advertising routes and you want to send traffic to and from those routes. So when you go to create your traffic, aka stream blocks, bound stream blocks as a matter of fact, you go into the traffic wizard and from there you will see all your emulated routes and routes, and then you can select them as a potential source or destination of your traffic. Spirent TestCenter also supports functional and negative testing via a frame editor as a raw stream block. So you can create a stream block and then you have access to all the parameters at the various layers and be able to create custom frames by adding headers. Let's say you want to simulate an OSPF LSA, but you want to modify some fields in there to make them invalid to see how the device behaves under that situation. You want to create invalid frames, insert checksum errors. You could also save these custom frames and use them at various points in your test. The Spirent TestCenter application has numerous summary views, both in the setup and the results. So you can see at the highest level the total number of things that you're emulating and describing per test. Also, you can see individually a single device, how many routes or LSA it has configured, or total across all the device on a port, for instance. So you have per test, per port, per router, per protocol, and even per protocol state summary views, which is especially useful for large-scale tests. So you want to run your tests and view your results. There's two different ways of running the test, either interactively, where you start and stop things using your mouse clicks and right-click function and pushing buttons, etc. There's also batch mode testing using the command sequencer. The command sequencer has a whole list of events that will occur automatically. There's also our custom and RFC 2544 test integration. While the test is running, there's various different types of results, real-time results for port level, stream level, and even protocol level statistics. You can chart statistics and events over a period of time so you can see cause and effect. For instance, if you withdraw routes, you can see what happens to the traffic in real time. There's detailed real-time logging. There's capture capabilities of your messages. You can decode your protocol events. You can activate and deactivate any type of entity in the test in real time and see what sort of effects that has. There's filters to sort results on a field of choice. So for instance, you're receiving MPLS traffic and you want to filter all the traffic on a specific or multiple MPLS label values. Ability to view the routes that Spirent TestCenter emulated routers receive from the system under test. And for highly accurate convergence testing down to 1 millisecond, Spirent TestCenter also supports high-resolution sampling. And there's cumulative, detailed, and formatted end-of-test results that is saved off in a SQL database and then can be viewed using the Spirent TestCenter Results Reporter. So the command sequencer is a way to create a list of events and then run those events all at once. It's also referred to as GUI automation, where instead of having to manually start and stop things, you can create a whole list of events. In this example, we see a command for BGP withdrawal routes. And so you can see that you can select which router, in fact, which routes, and which percentage of routes or category of routes that you want to withdraw at the time. And so these events can occur in sequence. It can actually add up to an entire test. So you might be setting up your routing and MPLS emulation to emulate a layer 3 IPVPN and all the routing and MPLS protocols that's required to do that, as well as the traffic that you want to send across each VPN. And then you can use the Spirent Test Center RC2544 or even Custom Test Wizard to perform an automatic throughput test, for instance, on the traffic in each VPN. And you can see how the device works and scales its throughput or performance as you increase the number of VPNs or increase the complexity of the traffic pattern. This slide gives you a picture of the real-time results browser and the statistics available. So this actually is BGP results. So you see the routing protocol state machine statistics for BGP. In other words, all the different types of BGP messages, whether it's advertised routes, withdraw routes, open messages, keep alive messages. Notice also from the results browser you can interactively start and stop the BGP events, or depending on the protocol that you're looking at, that protocol's events directly from the results window. You can chart certain statistics such as the receive rate on a port or even a specific stream associated with a specific VPN, and then integrated with the command sequencer you can set up a withdrawal event, for example. In this case it's looking at a RIP withdrawal event, and then when that event occurs the chart is actually delineated with it so you can see its effect on the item that you happen to be charting at the time. So the charts provide cause and effect sort of view, and also allow functionality for customizing, zooming in on events, measuring time events, all in real time. The Spirent TestCenter Log will actually keep track of events in real time as they're occurring. So you can select protocol events and select a specific router, a specific protocol and a specific router, and then in real time all the messages that are being sent and received from that device will be logged in real time. As I mentioned earlier, you can also activate and deactivate test objects. So it allows you to create a very large scale test with multiple objects and activate them as needed. This can be accomplished in the router configuration grids and or the edit routes dialogues as is depicted here. So various things that can be activated and deactivated include routers, routes, LSAs, individual LSAs, MPLS LSPs, multicast groups, and even host and stream blocks. Stream blocks being your traffic, of course. So being able to activate and deactivate these things allows you to have test cases with multiple protocols, and then you can troubleshoot things by inactivating or activating single protocols at a time. When an emulated router or a route block, for instance, is deactivated, all of its descendants will be set to inactive. So for instance, if you have an emulated OSPF router and you deactivate it, all the LSAs and such associated with that emulated router will be activated as well. And then they'll be grayed out in the GUI, so you'll know that they have actually been inactivated. When inactivated, you can no longer perform commands on them, start and stop, or even via the command sequencer. Also, other protocol-dependent functions, such as bidirectional forwarding detection, will not be performed on deactivated protocol. Thank you for taking the time for viewing this routing and MPLS overview module.